Well, our next question is coming from Teresa in California. And she watched our video on the Schwintek, where I was talking about lubricating the Schwintek, all those pieces, parts in there. And in that video, I called out the CRC Power Lube with PTFE, which is Teflon. Why did I recommend that product? Because that is exactly what Schwintek, or more specifically, what Lippert recommends for that system. So it turns out that her and her husband bought a used RV, and apparently the previous person had put grease in all those component pieces. And the question is, should she get that out and go with the proper CRC Power Lube product in the green can? Personally, I would. Why? Because the CRC Power Lube is the product that's specified for that system. I have nothing more to add to that. So yes, it's going to be a pain to get all that old grease off and clean all that and then put the spray on, but I like going to spec, because if something were to happen to that slide room, you know that the lubrication was the correct spec. We don't know what that grease is, okay? So that would be Darren's. I'm a purist, I'm a nerd, I like to do things to spec, and my answer would be to go ahead and degrease everything and then put the right product on. So I hope that helps you, Teresa, and happy camping. Our next question is coming from Ray, and it involves his air conditioner. Basically, the freezer's cold, but the refrigerator's too warm. Freezer's cold, refrigerator is too warm. He's checked his thermistor, and the thermistor is 18,000 ohms at 50 degrees and open at 32. So let's jump into that. If you're, I'm standing on a rock and it's messing me up here. That's what I get for standing down here in my creek, kind of in my side yard here. Anyway, it's a nice place. I figured I'd take you down here and do some answers here. So there's really no relationship between the thermistor and the freezer hot and refrigerator warm, okay? Why do I say that? Because it's a continuous loop. We've got a refrigerator video where I go through how the absorption refrigerator, it's a story of ammonia, and it changes, every time the ammonia changes states, it's either going to absorb heat or shed heat, okay? But that's a whole other video. We'll make a link up above on how heat makes cold. Overwhelmingly, when I get the question that their freezer is freezing but the refrigerator's too warm, my knee-jerk reaction is that it's a ventilation issue on the backside of the cooling unit, okay? There's other questions that I might ask. If you were a customer of mine, I might ask you to put like a cup of water up on the top shelf of your refrigerator, leave it there for a day, and then let me know the temperature of that. And that's what we're looking for there, is 37 to 40 degrees after, like, I don't know, a day or something like that. If the cooling unit can't shed heat, now the cooling unit's the metal part on the back side. So the refrigerator has the insulated box, and then you've got the cooling unit, which is all the tubings and all this metal stuff on the back side of the refrigerator. That's a separate piece that they bond to your insulated box, okay? So the cooling unit needs to have ventilation coming through it, okay? Now I've got another video where I talk about diagnosing your refrigerator. We'll make a link to that one, and I draw a little pretty picture of how that ventilation is supposed to work. And I've got another video where we found one that was not in a slide room, and there was this big open space above his refrigerator, and that air just gets circled around. So ventilation is so critically important to these absorption refrigerators. And I'm sorry to say that I've seen a lot of times brand new RVs where the manufacturer did not do it right. It's all over the board, high-end RVs down to simple RVs. They're just not installed correctly per the specification of the refrigerator manufacturer. The refrigerator manufacturer says this is how we want our refrigerators installed, and somehow the message isn't getting to the guys on the line that are making these RVs. Okay, so first thing, the freezer's freezing but the refrigerator's not cold. I want you to look for the proper ventilation of your refrigerator. Okay, if your ventilation is correct, then what I want you to do, let me set this down because I need two hands here. I've got my jacket over there. Okay, so I'm going to stand at the back of my refrigerator on the outside, and over here, it could be on either side, but I'm going to say that the chimney, the boiler, is going to be on the right. It's going to be wrapped in a shroud. You may have a cover over it, but you need to get to your chimney, your boiler, And then right here, you're gonna have this big vessel. That's where the ammonia and the water sits. And then you're gonna have these like coily, you know, round tubes that are going up. After your refrigerator has operated for several hours, it's not going to do this if it's been off for several hours. So leave the door open, you know, and let the thing work. This refrigerator needs to be working for you to check this next part. Let your refrigerator work for a while. I would say after about an hour or an hour and a half of that refrigerator working, feel the temperature of that boiler. It should be like really hot. Feel the temperature of the coils. They should equally be very hot, okay? Feel the differences in those two temperatures. If your boiler is hot, but these coilers are cold, and after the refrigerator, you've confirmed that the refrigerator's been working for at least an hour, 2 hours for a while, your boiler's hot, but the coilers are cold, you have a blockage. That means that that ammonia can't work its way through. Got another video where I talk about blockages. If your boiler is warm, but your coilers are really hot, then you have a leaker. And a telltale sign of a leaker is that yellow powder at the bottom of your boiler. It's like a sodium chromate. It'll dissolve in water. So if you boiler is warm, but the coilers are super hot, it's lost its pressure, the hydrogen has escaped, and that ammonia is just boiling up, but it's not doing any heat transfer because there's no hydrogen for the ammonia to vaporize into. I talk all about that on the other video where I got my little red pointy stick pointing stuff. So, for your issue, I would say check your ventilation first. If you've confirmed your ventilation is correct and you haven't made any changes to it, after your refrigerator has run for a while, do that temperature check to see what the temperatures are like. Okay? A correctly operating refrigerator, the temperature should be pretty close to each other, meaning you have good circulation all the way through. Okay? So, I hope that helps. Let us know in the comments what you found. Thanks for watching. So for our next question, we've got Tom here. Now, Tom doesn't tell us where he's living, but apparently he's got a lot of humidity in the location where his RV is stored, or apparently they've got it on a lake or something, about 80 feet away from the nearest shore cord where he can actually plug it in. And so his question is, he's put 8 damp rids in his RV, and he went to go check the mouse traps and things, and there's still a lot of humidity on the mirrors and things like that. So his, like, what are some other things that we could do? And so Tom, if you don't have electricity access to your RV, now he says that when he's there, he'll run extension cord 80 feet while he's there, but he doesn't want to leave it plugged in when he's not there, a safety feature or whatever. But so what comes to mind, damp rid is a good product, but it is a passive dehumidification process. In other words, that is to say, if there's humidity in the air and it comes near that little base with those little white crystal things in it, and humidity happens to be there, then it'll absorb it out of the air and transfer it to the bottom of that little tub there. But it's very passive. And active dehumidification, you need electricity, where there's a motor, there's a pump, and it's actually got a fan in it, and it's very actively cycling the air through it. We didn't really have a problem when we were living in Texas, but we moved up here to the Northwest. We're dumping about a gallon a day out of our RV just on any given day. So it is an issue. But to your point, Tom, is there something you could do short of electricity? I would stick with the damp rid product, okay? Understanding that it is a passive dehumidification process. A question I have for you, Tom, is see if you can figure out what's causing the humidity. Did you guys take a lot of hot showers and cook a lot of steaming type rice or something, and then all of a sudden you left and you closed up your RV? If that's the case, then before you leave, run the heater and open the vent and try to get some that humidity out, then close up your RV and leave. You got to figure out where the humidity is coming from. Then we have a chance to kind of abate that passively with the damp rids. Okay, so I hope that helps, and thanks for watching.